Right, it would seem that there was an issue with the stream key. Sorry about that. What had happened there was they changed the stream name key since the last few sessions. I don't know why that's happened, but it has happened. It might be something to do with it being unlisted initially. At the moment, it's public, but I don't think we'll have an issue of other people stumbling across our stream, so we'll carry on with that. So just be aware that the stream is actually on public, not unlisted at the moment. So today what we're going to do is we're going to start off with some enlarging shapes work. Okay, if you want to practice more transformations, you've got all these links to translating shapes, reflecting shapes, rotating shapes, and enlarging shapes, so you can practice those if you need more and you can't remember what to do at this stage. So here we go, we're going to have some enlarging shapes. It says drag the dots. This is taken from my maths, but you can't drag the dots. But what you can do is you can copy the shape and enlarge the shape yourselves. So here we go, drag the dots to form a new triangle under the enlargement, scale factor 2, center P. Have a go at doing a sketch of what that would look like. If you haven't got square paper in front of you to copy this, just draw a rough picture of how you'd go about doing it. And I'll give you just, I think, about a minute to do that. Right, took a little while to get my timer going there, so actually just give you 30 seconds off that time. Finish off. Right, we're going to stop there. So I'm just going to make that smaller. Right, to enlarge a shape, there's a couple of ways. The technical way to do it is to actually measure the distance from P. If we enlarge this shape, let's say B, to find B dash, we measure that with a ruler and then measure twice as far. So, but the easy way is actually to count the squares. 1, 2, 3, 4 down, 1, 2 across. So double that. We're going to go another 1, 2, 3, 4 down, and another 2 across. And we're doubling it because the scale factor is 2. So that's where B dash will be. And if we do the same with C, it's also going to be 4 down, but 3 across. So we're going to go from there, another 4 down, and another 1, 2, 3 across to get C here. A is 1, 2 down, 1, 2, 3 across. So we're going to go another 1, 1, 2 down, and another 1, 2, 3 across. And you can see our new shape is here. Now you know you've got an enlargement correct. If the scale factor is 2, and that side is 2, this side must be 4. That side's 1, and this side must be 2. So you know you've got a scale factor correct. At least you get 1 mark for at least getting the shape in the right size. So if it's a scale factor 2, then it must be double the size. So on this one, we're looking for a scale factor of 0.5, so the shape must end up half the size. Okay, so I'm going to give you 1 minute to have a go at drawing a sketch of what you think this one would look like. Off you go. Right, that's that 1 minute. You need to appreciate that my timer, your stream is lagging me by 10 seconds or so. So any questions you send through, there'll be at least a 10-second lag before I can answer them. Now we've got a scale factor of 0.5. So if we count 1, 2, 3, 4, 5, 6, 1, 2, then that's got to be halved, not doubled now. Because previously, if you went 4 down, we would then go 8 down, and then if we went 2 across, we went 4 across, so it all got doubled. Now, if we're going 6 down and 2 across, we need to halve that, so it's going to be 3 down and 1 across for our new place for f. And if you were to actually draw that, let's just draw a little line. Okay, from there to there, you can see it's halfway along that line. We're halving the distance from Q to F. So therefore, that's going to be F dashed. And then we can do the same. Now, once you've drawn where F is, if you know it's a scale factor of 0.5, as long as you're sure you got 1 point correct, you could draw the rest of the shaping, because we know G must be there and we know E must be there. Not there, missed there, because the shape must be exactly half the size. Let's just check that. Is it half the distance? It goes 1 down and 2 across to E dash, when before it was 2 down and 4 across, so that looks good. And G is 1, 2, 3 down and 2 across, whereas before it was 6 down and 4 across. So our shape looks good. Now, if you want to make sure you get the working marks, do draw your construction lines in. Okay, so the construction lines should be drawn in, really, afterwards. But I find this way of counting squares to the place to be a lot easier than using a ruler. Obviously, if your corners aren't on perfect squares and they're not nice units like these, then you might need to use a ruler to do it. Okay, those two are quite straightforward. This one is a little bit more interesting. We're going to enlarge shape A by scale factor -3. So I'm going to enlarge this shape here, scale factor -3. So I'm going to give you just over a minute to have a look at that one. So it says 2 minutes. I'm going to give you about 1.5 of that timer. Okay, I'm just going to use the timer for 2 minutes because it's easy to get going. I'm going to give you 1.5 minutes to have a go at this, because this one's just a little bit, you've got to think a bit more to do it. Okay, that should really have been enough time for you to get a good go at that question and see if you're doing it the right way. It doesn't matter if you don't finish these questions in the purpose of this video, it's just to make sure you are getting on the right lines. And what you can do is you can copy my things across to your section, rub it out, and have another go at these questions again later, if you want extra practice to make sure you can still do them. I would advocate any of the videos that you see me do and you didn't know how to do them before I went through the video, you should actually try and do those questions again about 2 days later. Okay, try and do those questions again about 2 days later to make sure you can still do them, because it's quite likely you'll forget them. If you do them again 2 days later and you've got it the same as you've got it now, then you will find for the exam next week you should be okay. Now, the trick with this one is a negative enlargement. That means the shape will need to be drawn on the other side of the point. So where do we draw it? Well, we can use our counting method. Let's just look at how we're going to move this point. So if we count 1, 2 down, So we're going to go, sorry, I'm going to just change the colour of those crosses so we can see we're going 1, 2 down. Make it a bit bigger. 1, 2 down, and then we're going to go 1 across that way. Then what we do is we go, it's a scale factor -3, so the distances are going to be trebled, but we're going to go the opposite way. So we'll go 1, 2, and if we want to treble it, we need to go to 6, don't we? 3, 4, 5, 6 up, and we went 1 across. Now we're going to go in the opposite direction, 1, 2, 3, and our new point is going to be here. So we call that point is going to be there. Now, if we do this one here, then we're going to go an extra 1 down. So we went, was it 2 down before? We're now going 3 down and 1 across. So we're going to need to go another 3 up. 1, 2, 3, and we're still going to go only 3 across, and our new point is there. Now, hopefully, you begin to see where the rest of the shape is going to go. Now, if we go to this corner here, we're going to go an extra 1, 2, 3 across. Times up by 3, that means we need to go 9 across from here. 1, 2, 3, 4, 5, 6, 7, 8, 9. Our new point is going to be there. I'm just going to rub out some of this working, so as you can see what I'm doing. I'm just going to rub out these lines because these are construction lines. They're not part of our new shape. I'm just going to rub them out so you can see what we're doing. Now I'm going to do this point. I've done that point, and I've done that point, I've done that point. I'm going to do this point now. I'm going to go 1 down, 1, 2, 3 across. So I need to times this by 3. So I'm going to go 1, 2, 3 up, and then I'm going to go 9 across. And it's obviously going to be level with here, isn't it? 1, 2, 3, 4, 5, 6, 7, 8, 9 across. And it's good to do every single point because it's a check that your other points are okay. So I'm going to rub that out now. And now I'm going to do this point, which is only 2 across, so that will be 6 across on my new shape. 1, 2, 3 up, because timesing this distance by 3, times the 2 by 6, 1, 2, 3, 4, 5, 6. So our new point is there. Now, if I've got this right and not made any mistakes, the next point is going to go here, because we need to keep our shape looking the same. So 1, 2 down, 1, 2 across, 1, 2, 3, 4, 5, 6 up, 1, 2, 3, 4, 5, 6 across, and it is there. So we put our new point in here, and here's our shape. And we can see that all the sides are 3 times the length. So you can see, even though it's a scale factor -3, all the lengths are 3 times the length, and it's minus means it gets drawn on the other side, and the distances are on the other side of the centre of enlargement. You can do this using a ruler, so you can measure from here to here, and then we can measure 1, 2, 3 of those diagonals there. So that's the proper way to do it, is actually to use a ruler. As you can see, I haven't got a ruler on me on this one, and oh no, it's wrong. You can see I'm trying to fix it. So I'm going to go 2 across there, 2 across there, 2 across there. There we go. There's some rulers, construction lines drawn in for you. So that's how you do enlargement scale factor -3. So you've got through all the types of enlargements. So we've got scale factor normal one. We've got one where it gets smaller, and then a negative one where it gets drawn on the other side. So do remember, negatives get drawn on the other side. Okay, that's the key thing. So that will do for our transformations this morning. Let's have a look at a little bit of stats, okay, for today. We did this quite recently. Let's just jump into to this question here on scatter diagrams. Let's just do question 3 to start off with, and give you 1 minute to think about these answers. Okay, that should have been plenty of time to think about these answers. It should hopefully be nice and easy for you. Sales of ice cream as the temperature rises in summer. So as it gets hotter, so that's going to be our dependent variable, we'd expect the sales of ice cream to go up. So we'd expect that, sales of ice cream, as it gets hotter, we expect the sales of ice cream to go up. So therefore we expect an upward line. So that's a positive correlation, is what we expect there. Okay, so we expect a positive correlation. Okay, the value of a mobile phone as it gets older. So as it gets older, we would expect the value to go down. So it's very rare that mobile phones get more expensive as they get older. So therefore we have a negative correlation because one's going down as the other is going up. And the amount you get in a maths test, the further you live from school, we don't really expect that to have any bearing on our maths, the distance we live from school. So therefore we would say there's no correlation. It might be bizarre that there ends up being a correlation, but you wouldn't expect the distance you live from school to affect your maths ability, so we have no correlation. Now, okay, you've got two things to look at here. Let's just give you a minute to just think about this question here and get your answers thought out for this one. Right, let's just pause that there. We're having problems with the stream health by the looks of things. Let me just check my connection. Right, we're looking at two scatter graphs, and we can see that this one, one goes up as the other goes down, and this one, the one goes up, the other goes up. So the positive correlation is going to be graph B, and obviously graph A is a negative correlation. Now, which one shows a stronger correlation? Well, to work out which one shows a stronger correlation, you want to see if you can draw. Let's get a better line than that. Let's draw a proper line. Right, it ended up being two lines, and draw a line through this one. Where the points are closer to the line, okay, you have a stronger correlation. So the graph with the stronger correlation is graph A, because the points more closely follow the line. Now just check my connection. It all should be good. I don't understand why we're having a little bit of lag, but we've got a little bit of lag. So anyway, that's pretty much everything you need to know about correlation, whether you're positive, negative, no correlation, and how to tell if one is stronger than the other. Right, so we've now gone through this morning enlargements with transformations. I'm not going to go through the easier transformations of translating shapes, reflecting shapes, and rotating shapes. If you want to revise those, I suggest you go to My Maths and do that there. We've now done the stats we need to do for the next week, and I've not covered this number work. So you need to make sure you can do all these fractions questions, especially the ones down here. You need to make sure you can do the fractions questions down here for your non-calculator paper. You expect to be able to do fractions. You should be able to do all of these already. Okay, but I'm not going to suggest you have to get 100%. Just go through them and check you can do them. to make sure you there's no gaps in your knowledge with regards to fractions. And what you should do is you should make sure, especially on these ones, you can get 10 out of 10. Right, what we're going to now look at is some Venn diagram work. Okay, hopefully your Venn diagram is good. We'll just start off a nice straightforward one here. I'm going to give you just a minute to have a look at this, and then we'll move on to a trickier question and see how you get on with that. Right, okay, we're now lagging at about 40 seconds. I will keep checking for your questions after the lag has stopped. Okay, just thought I'd let you know that that's how far it'll be before I see any questions you come up with. Right, we're going to consider this. We're going to put the numbers 1 to 10 in here. Even numbers, prime numbers. Well, 1 is not prime. Okay, big mistake. Often people think it's going to be a prime number. A prime number needs to be a multiple of 1 and itself, two numbers. It needs to have two factors, 1 and another number, which is itself. So 2 is prime, but it's also even. 3 is prime because it's 1 times 3 and not even. 4 is even but not prime because it's got factors 1, 2 and 4. So that's 3 factors. 5 is prime. 6 is not prime but even. 7 is prime. 8 is not prime and even. 9 is neither prime nor even. And 10 is even. If I pick one number at random, what's the probability that it's a prime and even? So we got 1 out of 10. Okay, prime and even is in here. Now, to use set language, that would be set if we wanted to call, let's call A the set of even numbers and B the set of primes. Then if we call this set A, this set B, this be equal to A interset B. Okay, if I pick one number, what's the probability that it's prime and even? If you have an and, then that's the same as an intersection. So all the way through this, I'm going to give you the set notation that goes with these questions, okay, even though they're quite straightforward. If I pick one number at random, what is the probability that it's prime and not even? So we've got prime, which is B, and so it's interset, not even, so A dash would be prime and not even. So we're looking for the probability of B intersect not A. So we're not A, but we're prime, is going to be these numbers here, 3, 5, and 7, because it's not in A and it's prime. So that's going to give us 3 out of 10 for our probability. Okay, right, let's just jump through to a slightly harder question. So we're going to go through all them. They should all be quite straightforward. So here's what we call a challenge question. Let's see how you get on with this challenge question using Venn diagrams. I want you to draw a Venn diagram for this situation with the number of things in each group. Okay. And I'll give you 2 minutes to just have a go at this whole question. I had my microphone turned off there, now got it back on. Right, this probably will take you a bit more than 2 minutes without a calculator. But let's just try and draw ourselves a Venn diagram of this. So let's get ourselves a rectangle. Let's get ourselves a circle. And get ourselves another circle. Oops. Move that to there. Right, so we know that the easiest thing to put in is the 1,000 people here who didn't take a camera. So this is our camera, and these are socks with sandals group. So there was 1,000 straight away we know that didn't take a camera, and also avoided the fashion faux pas, a combination of sandals with socks. Now we've got 328 took a camera and 204 wore sandals with socks. Now we can see that there's only 352 that can fit into the camera and socks and the socks, so there must be some overlap. So let's work out how many we've got altogether here. So that's 532. So we've got 532 in there. So we must, to find out the overlap, we take away the 352. Okay, we take that away because we can only fit 352 left in here because there's 1,000 here and we've only got 1,352 altogether. So we take that away to find out what our overlap must be. So take 2 away, we get 0. Take 5 away from 3, we need to borrow 1 across. So 13 take away 5 is 8. And then we get, sorry, that's going to be a 4 there. 3 away from 4 is 180. So we now know that our overlap must be 180. And then we've got to take that away from, so we've got 3 to 8 to take away 180. Let's just do that. 0 away from 8 is 8. 8 away from 2, again, we're going to borrow 1 across. So that's going to be 4, and that's going to be 148. Or you could just count it up. Here's another way to do this in your head. 20 up to 200, and then we've got 128 from 200, plus 20 is 148. So we've got 148 had a camera only. And then we've got 204 take away, what was it, 180, and you should be able to see 20 up to 200 plus 4 gives me 24 in here. How many people took cameras and wore sandals and socks? So that is the yellow bit here. So we know that that's 180. What is the probability that a randomly selected visitor took a camera but did not wear sandals with socks? So they took a camera, so we're in this area here, but we didn't take the sandals and socks, so it only leaves us this bit here. Okay, we don't need this bit, the 180, so therefore it's going to be 148. But we want it says probability, so that's out of 1,352. Now if it doesn't ask you to cancel down, you can just leave your answer like that. If you're going to cancel down, we can just divide that. We can see 2 goes into both, so that's going to give me 74. Just start off something simple that goes into both. So 2 goes into that 6, 1 over, that's going to be 7, 1 over 6. We can still see 2 goes into that. So that's going to give me 37. 2 into that's 3, 3, 1 over 8. And 37, I do believe, is prime, so nothing's going to go into that. The only way you can cancel down is 37 goes into 338. And I don't really want to try and work that out now on the video. But it doesn't ask us to simplify, so that's perfectly good enough. So a randomly selected camera carrier wore sandals with socks. So we know that they are camera carrier already. Okay, we know they are a camera carrier already. I'm just going to zoom in on here so I can rub some of these colours out without ruining it. So we know they're a camera carrier already. Right, so this is called conditional probability. We know they're camera carrier already, so we know we're in this region. So there are 328 camera carriers. So we know we're just looking at, out of those 328, who wore sandals with socks. Okay, well, it's just this lot here, the 180. Okay, they're camera carriers, and they also wore sandals with socks. And again, you can go through the process of cancelling that down. Now, we didn't have this question. I'll just give you a minute just to think about this. a random selected wearer of sandals with socks. Okay, so you're told they've got the sandals with socks, but they also carry a camera. I'll give you 20 seconds, just about 20 seconds to have a think about that one, because you've got all the numbers. And see if you can come up with an answer for that, because these are tricky questions in part B. Right, that's enough time to have a look at that. So we know we've got a randomly selected wearer of sandals. So we'll just get that. Oops, does it undo that? Because I actually rubbed out too much. Let's just get rid of the green and try just to get rid of the blue. Keep getting that point there. So too much zooming. So we know we got a wearer of sandals with socks. So let's just highlight the sandals with socks group. So that's that group there. But they also carried a camera. So that's this group here. And we know there is 204 who wore socks, sandals with socks. So it's out of 204. There are 180 that carried a camera. So that's our probability. Okay. Now, I just had a question about, do we need to know the intercept notation? Yes, you do. You also need to know the union notation. So if we wanted to find, now here's an interesting one. I'm just going to cover two things that you might come across. So we want N. I'm just going to change the sandals and socks set to call that S. If I want to know C union S, and how N means how many things are in C union S. And union means or. So if I actually shade in green, the union is all of this, and all of this. You have to add all those three numbers. And we've already worked out what that must be. We've worked out that must be 352 back here. So there are 352 things, because N is how many things are there, in C union S. Okay. We can't, on this question, we wouldn't get anything other than N, how many N's, because we don't know all the things that are in each different set. We've just got the number of elements in each set. Okay, so the union is when you include both the C or the S and the middle bit as well. Right, we're running at 35 minutes. I think we've gone over plenty this morning. So I will do another in the next lesson. I will actually look at more Venn diagrams with the notation for you. Okay, I'll look at more notation. We have now covered the straight lines. We've covered the inequalities. We haven't done much in the way of 3D trig, because it's not 3D trig we need, it's 3D Pythagoras, so I'll have a look at that. You should go away and look at those, make sure you're happy with those. We've now done Venn diagrams. We did all the algebra, but we didn't do indices, so we'll do indices next lesson, along with the sets work. We've now looked at this bit of stats. You should go away and do fractions. Probability, we've covered all this probability, but you should make sure you go over this. Okay, and I think that's all the sections that we need to do from here, so hope that's helpful. Go away and work on these again between now and next lesson. Make sure you can do all the questions we've covered today on Venn diagrams, on transformations, and I'll try and put some more scatter diagram questions in another page for you to practice. Goodbye.